So in this warm-up problem, we're going to kind of have a flashback problem where we have to solve quadratic equations, meaning we have to find the x for the equation that has x squared in it. So you might remember if you have an x squared and it's a trinomial, the best way to solve is by factoring it into two factors where x's are in front. And then what happens is these two x's, when they multiply and you FOIL, that's how you get the x squared. But we have to figure out what two numbers go here to make it an 8, but add to give us a 6. So two numbers that multiply to give us 8 are 4 and 2 and 8 and 1. So we think about numbers that multiply to get us 8. So two numbers that can do that are these two pairs. But they also have to add to get the middle term. So the only two sets that do that is 4 and 2. So I'm going to put 4 and 2 down. And they're all positive signs, so they're probably all going to be positive signs. And this side's going to be 0. So I'm just going to drop down the 0. Let's see if this works. So x times x is going to give me that x squared that I'm looking for. 4 times 2 gives me that 8, but if I add 4 and 2, I'll get that positive 6 that I'm looking for. So this does work, and we can set each factor equal to 0. And then from there, it's really easy to solve because we've gotten rid of the x squared. We've changed them into factors. So now this x is to the first power, and we can move over the number here. So if I subtract over 4, it looks like my x is equal to -4 for this one. If I subtract my 2 from this one, it looks like my x is equal to -2. And there we go, we have our solutions. X equals -4 and x equals -2. And we talked about this before, but anytime you have x to the second power, there should be two answers, and there are. This one here is a little bit more simple. You have x squared plus 4. So what you can do if there's only two terms is you can move over the other term and try to get the x squared by itself. So I can subtract over the 4. Oh, excuse me, I meant to write 4 on that side. Let me fix that. Subtract by 4. And then x squared comes down. This becomes -4. And then you guys might remember, how do we get rid of a square? We take a square root on both sides. X comes down. And let's think about this for a moment. Anytime we have a negative under a root, you might remember you get an imaginary number. So we put an I there. Now, anytime we take a square root, we have a positive and negative in front of our number. But the square root of 4 is 2. Because if you think about it, if you break it into a factor tree, 2 times 2 gives us 4. And so that's a pair. So square root of 4 is always 2. Because in this case, the two numbers that multiply to give you 4 is going to be 2. All right, so it looks like the square root of -4 is plus or minus 2i. Some people might write it as positive 2i and negative 2i, like this. Or they might just use a plus and minus symbol to say that it can be both positive and negative. But notice again, you have two answers. You have a negative 2i and a positive 2i. So you're probably wondering, why am I showing you, this type of problem where you're solving by factoring with quadratics when we've been dealing with x to the third power and higher? Well, it's because sometimes you might encounter things that are still x to the second power, and we still need to know how to deal with those. And plus, we're going to be using a lot of factoring skills, and you'll see that into play when we get to the problems down below. But before we get into today's definition, let's remember something important. There are many methods for solving quadratics. So quadratics meaning x to the second power. Which method always works even if you cannot factor? So one of the dilemmas when we're solving for cubics is we'll run into actually some quadratics equations, and then we can't factor them. And so if we can't factor a quadratic, you guys might remember, if you can't factor a quadratic equation, you would use the quadratic formula. And the quadratic formula says that if you have it in standard form, so ax squared bx plus c, and it's set equal to 0, so the other side is 0, then you can use the formula x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So this formula here helps us figure out and solve for x. All right, let's get into today's definition. So when it comes to solving cubic functions or cubic equations, what you have to do is there are two simple methods you can apply. One is you can use grouping. Now, grouping is probably the easiest if there are 4 terms. That's really important. So if there are not 4 terms, do not try to apply grouping. It might not work. You might need to use something else. You can use sum and difference of cubes if you're in a situation where you only have like 2 terms, say like something like this, and it is a perfect cube, then you might want to try sums and cubes, sum difference of cubes, that formula, and you can try to factor that way and see if you can solve for x. So basically the goal for solving for cubic equations is start by factoring, then setting it equal to 0 and solving each factor individually. And I'll show you how to do this using these 2 examples. Let's start out with if you have 4 terms. So if you have 4 terms, what we're going to try to do is use grouping. And so if I were to use grouping here, I would make sure that they are from highest power to lowest, which they are. And so from here, I would group up the first 2 and then group up the last 2. This one has an x cubed, this one has an x squared, so I can pull out at least an x squared. We always pull out the lowest exponent. So I leave behind an x and I leave behind a 5, right? Because I took away 2 x's from here, so that's only 1 x left. I took away this x squared, but there's still a minus 5 here left. This one here, there's a 4 and a 20, but there's a minus sign here. So notice we're dragging out a minus sign. And if I take away a 4, a 20, you can also take away a 4. So I leave behind an x and a 5, but this is going to be a minus 5. Here's why. So I took out a 4. That means the 4 is off of this x now. In the second term, you take away a 4, you have left a 5 because 20 divided by 4 is 5. But it has to be a minus 5 because if this is a minus 4 on the outside, if you were to redistribute, negative 4 times negative 5 gives me back a positive 20. So that has to be a negative 5. Now this side's still going to stay 0. But I want you to notice that both of them have an x minus 5, so you can pull that out. But you leave behind an x squared and a minus 4. So you left behind an x squared and a minus 4, so we're going to always put that in another parentheses to show us what is left over. Notice how you have now 2 factors, and this is good. So now that you have it in 2 parentheses, we can set each parentheses, so 5 minus x minus 5, set it equal to 0, and x squared minus 4, set it equal to 0. And this looks very similar to the quadratics we were solving in the bell work. And it is. So what I can do, I can add 5 to this side, and it looks like my x equals 5 for my first answer. So that is my first x value. I can add 4 to this side, and so x squared comes down. This is a 4. On the right side, I have to take a square root to get rid of the 4, or get rid of the square, my bad. Square root of 4 is 2, but it's a plus and minus 2. So it's a positive 2 and a negative 2, because anytime you take a square root, you have to account for the positive number and the negative number. All right, let's take a look at everything we have seen. So what we did was, because we noticed there are 4 terms, we did grouping to factor. And once we got to our factors here, we set each parentheses or each factor equal to 0 and solve for x. This makes it easier to solve when you do factoring because it's breaking down the exponent and making it easier to handle and get x by itself. So that means in the end, x is equal to positive 5, positive 2, and negative 2. Guess what? You have 3 solutions for x. And this should make sense because your highest power is 3. You should have gotten 3 solutions. All right, nice work, guys. Let's try out B. So B only has 2 terms, and so you cannot use grouping here. Instead, you have to use the sum of difference, or sum and difference of cubes. And that goes back to using one of those formulas. you might remember using SOAP. So like if you have a cubed plus b cubed, in our case, this is where you break it into two parentheses. Oops, let me see if I can bring that down. There we go. And you have a and b. So if I use SOAP here, this is going to be same, opposite, always positive. So it's going to be a squared, a times b, b squared. So this is the formula we're going to need to apply because we have a plus sign here and there's only two terms. And this is a perfect cube as far as I can tell. But we need to figure out what is our a, what is our b. So let's figure that out. So a has to be, I guess in this case, an x because x cubed gives us x. The cube root of 64 is 4. I had to think about what number to the third power gave me 64. And you can do this in a calculator where you take a cube root of 64. Or you can just play the guessing game. But what I did was I did 4 times 4 is 16. 16 times 4 is 64. So that's how you can guess your way to the right answer, is pick a number that you would think is relatively close to being the cube of this number. So it looks like my a is x and my b is 4. So now I can try to factor. Now remember, the right side is always going to be a 0, as you can see, because we're going to set these factors equal to 0. So our a here is going to be x, and our b here is 4. And then this is a minus and plus sign. So this is going to be x squared, 4 times x, because a times b is going to be 4x. And then over here is going to be our b squared. So 4 squared is going to be 16. All right, I have my factors now, so I'm going to set this equal to 0. So I'm setting each parenthesis equal to 0. This one will be very easy to solve. As you can see, I'm going to subtract over 4, and x is equal to -4 for my first answer. This one becomes really challenging. You can sit here and try to factor this trinomial, but you will realize this is not factorable, because one of the things I said in an early journal is that anytime you're doing a sum and difference of cubes and you use this formula, this is not factorable. So this cannot be factored. Or I'll just write cannot be factored. So you can try to see if it can be factored, but I'm going to tell you right now, don't waste your time, because you won't be able to find any factors at work here. Because think about it, let's write some factors down that could possibly work. 4 times 4 gives us 16. 16 times 1 gives us 16. 8 times 2. But there's no way to add any of these in combination to make a -4. So this is going to fail. And so this is where we have to use the quadratic formula to solve for x, because it's a trinomial, and also this is already set equal to 0, so it's already in standard form. So our a here is 1, b here is always a number in front of x to the first power, so -4, and c here is 16. So just as a quick reminder, the quadratic formula is x equals -b plus or minus the square root b squared minus 4ac all over 2a. So if you need to refer to the quadratic formula, here it is. Now, I'm just going to write out the quadratic formula down here and plug in my numbers. So my b is a -4, so that's going to be -4 plus or minus the square root, or b squared minus 4ac, so my a is 1, my c is 16, all over 2 times my a, which is 1. All right, once I've plugged everything in, I'm going to do my best to clean it up. Like, I notice there are 2 negatives here, so I'm going to make this a +4 now. I'm going to clean inside the root. So this is a -4 squared, so that makes it a +16. I'll bring down this negative sign. 4 times 1 times 16 gives me 64. And the bottom's a 2, because 2 times 1 is 2. So if I subtract the inside of the root, 16 minus 64 makes it a -48, which also reveals to me why I was having such a hard time factoring, is because this is imaginary numbers. Imaginary numbers are really difficult to factor if there's a negative under the root. So in this case, I'm going to try to clean this up. Remember, if you have a negative under the root, you're going to get imaginary numbers. So I'm going to put the I outside in front and the 48 inside the root. So now I can just deal with the positive root. So I changed this negative 48 to an I, so I just remind myself that this is imaginary. The next thing I want to do is probably simplify the square root of 48, because I think this can decompose. So two numbers that multiply to give you 48 is 12 and 4. 4 can decompose in 2 and 2. 12 can be decomposed as 4 and 3, and 4 can be decomposed as 2 and 2. So I've already decomposed 12, 4, and this other 4. So it looks like I have two sets of 2's. So 2 times 2 gives me 4. Then I have a leftover 3, so 3 goes back in the root. So it looks like this here is 4 plus or minus 4i square root of 3. And then there's a 2 in the bottom. So what I did was I put the 4 in front and then the I just next to it because it kind of looks better with the I next to it like a variable. And then a square root of 3 because I had a leftover prime number. All right, from here I could reduce this just a tiny bit more. This is a 4, and a 2. They all divide by 2. So 2 divides into 2 2 times. 2 divides into 2 times. 2 divides into 2 one time. So I can really write this as 2 plus or minus 2i square root of 3. And I'm going to bring down my x now. That was in the front. So I finally have my answer here. And this was quite complicated to find, which is why it's not possible to factor. So it looks like x equals negative 4, but x could also equal 2 plus 2i square root of 3, or x can equal 2 minus 2i square root of 3. And those are my 3 solutions. All right, that's it for this video. In the next video, let's practice more problems similar to these.